Hey there, here to go over numbers 5 and 6 only, doing an example for each of those, so I'll only be doing 5 and 6. It's a little too late to do 7 and 8, and I think it's going to run long anyway. Alright, so 5 and 6, find the area bounded by the two curves, f of x equals x cubed minus 4x, and g of x equals 1/2 x cubed minus 2x. I forgot to mention that f of x is this function, g of x is this function. Alright. So it's basically top minus bottom plus top minus bottom, the integral of them. So let me do my own example here, and my example is f of x equals, let's see, let's go ahead and zoom in here. Alright, so f of x equals x cubed minus 5x squared plus 6x. And g of x is equal to x squared minus 2x. Alright, so this is a non-calculator question, so I will be giving you the two functions and their graphs, so I'm going to go ahead and graph them. Zoom 6 never works. I don't know why. Okay, so here you can pretty much see our double areas right here. I'm going to go ahead and make a sketch. I'm going to kind of do it off to the side so I can work on the right hand side more so. Alright, so my sketch. Okay. Alright, that's f of x, that's the cubic. And then Lord help me. That's a terrible. Okay, so I wasn't thinking there. Wasn't thinking. And so that's g of x, that's my quadratic. Alright, so it's something like that. I'm finding these two areas. Okay. So I'm finding their intersection points. That's what I want us to be focused on. Yeah, these two are x-intercepts, but they're intersection points. A, B, C. Now, also the next thing I want you to be focused on is writing your integral to start out with. Alright, I know I'm integrating from A to B, it's a top minus bottom. Okay, integrating from A to B is a top minus bottom. From A to B, f of x is on top. So I'll write that there. Alright, and I'm going to add the answer of the integral from B to C. G of x is on top right here in this part of the area. Okay, now this is non-calculator, so anything from here on out you have to do on your own. Alright, so let's go ahead and fix these up with our functions actually in them, and then we'll find our A, B, C, and C. So f of x I'm just going to do the first integral. Oops. So there's my first integral from A to B. Alright, let's go ahead and do the second one. And I basically know that this is going to be the opposite of all the signs of the first one. I'm pretty confident of that. Okay? I'm pretty confident of that. So B to C. So I'm basically going to add these two integrals. But what does A and B equal? That's my problem. Okay, so A, B, and C. I need to find A, B, and C. So there's where I'm going to find my intersection points by doing f of x is equal to g of x. Okay. Setting them both equal to 0. Or setting them equal to 0. Setting it equal to 0. Sorry. Now I can factor this. Well, here I go. I got my GCF. And oh, I can factor this. Oh yes, I can factor that. Oops. That factors into, whoops, I'm all off the paper. X minus 2x plus x minus 4. So here, x minus 2 equals 0, x equals 2, x minus 4 equals 0, x equals 4, bada bing, bada boom. And then, oh, don't forget about x equals 0. So 1, 2, 3 intersection points. Let me zoom out. Yep, we definitely have 3 intersection points here. Okay, so that should give you all 3 intersection points. So now, obviously, this is A, this is B, and this is C. So let's just go ahead and do this one first. So I'm just going to do the integral from A to B from 0 to 2 of and I'll go ahead and integrate. You don't need the plus C, but I like to be tasteful. Simplify. Plug in. Here's where I like to get fancy. 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 squared is 4. I should have just wrote 16. Minus, plug in 0. Well, that's just going to be 0, right? 0 minus 0 plus 0, oh, is 0. Alright, so here I get 4 minus 16 plus 16, and that's gone. So equals 4 units squared. Now that's only for this first part right here. Remember, I have to add. So I have to add the integral from 2 to 4 of negative x third plus 6x squared minus 8x dx. So now I'm going to put a plus sign and figure this out. Okay, so now let me go ahead and zoom in here because I'm probably going to have to write a little bit smaller. I'm running out of room. Okay, now I integrate from 2 to 4, the opposite, or the other one. Might not remember that it was the opposite. I'm skipping right to my stuff right here. I'm skipping right to it. Alright, and then I have, getting fancy, 4 to the 4th power, what is it? 256. Alright, plus 4 to the 3rd power, what is it? 64. Plus, minus 4 squared is 16. Minus, plug in 2, but I already did up here. I already plugged in 2 up here. Okay. So I already plugged in 2. So I kind of know what those things are, but it's a different equation, so I guess I shouldn't jump the gun so quickly. It's a different equation. It might be different, so let me just go ahead and be safe. I'd rather be safe than sorry. Plug in 2 again. 16. 8. That should be a minus, shouldn't it? Oh my goodness. Minus 2. Wait, that was squared. Okay. 4. Alright. So, alright, now we're almost done. We just got to figure this stuff out. So, and the 4th of 256 is 64, so negative 64. 2 times 64 plus 128. Negative 4 times 16 is negative 64. Minus, those already cancel. A 4th of 16 is negative 4 plus 16. I hope y'all can see all this. I'm running off. Okay. Minus 16. So those cancel. And 2 negatives make a positive 4. So you have 128 plus 4 equals 132 units squared. So remember, we had to add the answer for this integral right here plus the answer for this integral right here. So 4 units squared plus 132 units squared equals 136 units squared. And that's my story, and I'm sticking to it. Let me go ahead and pan out in case you need a pause. Let's see. I think my thingamajig's a little too close here. There we go. So there you go. That's the whole thingamajig worked out right there. Now hopefully this helps you with the double areas. It's a lengthy problem, it sure is. Next problem, let's move on. Okay, is this was the double areas problem. Now you might not need to factor this to find the intersection points. You might be able to take square roots. Okay? So just keep that in mind. You might have to do a GCF and just set the thing equal to 0, and it might end up being something really easy. Okay? Alright, so, and you won't have to factor like I did right here. You might have to do something easier. Alright, so let's move on to an example for number 6. Alright, non-calculator, positive, negative area. So, basically this is a short and sweet one. I'm going to explain it. It shouldn't take long. Basically we've got the rule. Alright, we've got the rule. Excuse me, I need more paper. Let's say I have a function such as cosine x. Let's say I want to find the area, and you know, I can talk about this one. Basically, you have positive area here, you have negative area here. On the video for the notes, I said to make the negative area positive. So if this is a and this is b and this is c, your integral will look like the integral from a to b, okay, of f of x dx minus the integral from b to c of f of x dx. That's it. That's all you have to do. So let me do an example of that. Y equals cosine x. Let's find the area bounded by y equals 0. Oh, sorry, no. X equals 0, x equals 2 pi, f of x, and the x-axis. That's a mouthful, but it's pretty simple, okay? You can copy this down if you want. I think it's pretty simple. I don't even know if it's worth copying down. Okay, so here we go. Here's cosine. It oscillates from 1 to -1. Bam, bam, and that's it. From 0 to 2 pi, that's it. Now if I'm restricting it to x equals 2 pi, x equals 0, f of x, or I'm sorry, y, we can name it f of x, and the x-axis, that's going to create this bounded area. Well, this isn't 2 areas, but it's 3 areas. It's a great example. You got an A, you got a B, you got a C, you got a D. Okay? How do I find these values? Well, same thing for up here. You're just going to set the function equal to 0. Set the function equal to 0. You're going to do f of x equals 0. And you're going to solve. And that'll give you A, B, and C. Well, I already know A and D. I need to find B and C. So I set cosine x, I set cosine x equal to 0. That's the function. I set the function equal to 0. F of x equals 0. That's cosine x equals 0. Now I know where cosine x equals 0 at x equals pi over 2 and 3 pi over 2. I know that from my unit circle. So I have to do 3 different integrals here. I got my integral, I got my A, B, C, and D. I have to do the integral from, sorry, not A to B, from 0 to pi over 2. And I just do the regular old integral, f of x dx. This is negative, so I'm going to minus it, which will make it positive. Integral pi over 2 to 3 pi over 2 of f of x dx. And that's positive, so I don't need to minus it. I just add it from 3 pi over 2 to 2 pi of f of x dx. Alright, so that's integrating 0 to pi over 2 of cosine x dx minus integrating from pi over 2 to 3 pi over 2 cosine x dx. And no, you can't combine these because they got different A's and B's and C's and D's. You can't combine them. You got to write them as different S's if they have different boundaries, different limits. 3 pi over 2 to 2 pi cosine x dx. So what's the integral of cosine? Sine. Evaluate 0 to pi over 2 sine x plus c minus evaluate from 3 pi over 2, 3 pi over 2 sine x dx plus evaluate from 3 pi over 2 to 2 pi sine x dx. Alright, so there we go. Now, so bada bing, bada boom, bada boom. Alright, so now all we got to do is plug in our stuff. So this one ends up being, plug in pi over 2, you got sine pi over 2 minus sine 0 minus sine 3 pi over 2 minus sine pi over 2 plus sine 2 pi minus sine 3 pi over 2. Okay, so we got all that. Now what's sine of pi over 2? 1 minus 0. And that's it. And that's negative 1 minus 1. And that's that. Plus 0 minus 1. And that's that. Okay. Oh, I'm sorry. I got that totally messed up. That's 0 minus negative 1. Let me see. Did I get that? That's not negative. Okay, that is negative. That's positive. All right, that's negative. 0 minus negative 1. All right, so that becomes positive 1. That's negative 2 minus, and that's 1. So that becomes 2 plus 1 equals 5 units squared. Okay, hope that helps, and I hope it wasn't too long. All right, if you don't have time to work on your take-home test, that's tonight, that's fine. We'll have plenty of time in class tomorrow. All right, so let me pan out real quick. You want to pause it at the end, take a look at all that, good to go. All right, guys, have a good night. Peace.